fun. And so, oh, I didn't. Oh, I didn't. If you haven't downloaded this, it's in the first three, I think, lectures now are out there. But anyway, let me get started with the first one, at least get through as much of it as I can. So what we're going to talk about in this class is anatomy and physiology. Even though we named it morphology and function, that's because when I was fighting to get this course originally devised, some guy in Tallahassee said, I can't name it anatomy and human anatomy and function. That's a lower division class. I have to come up with something else. So that's where the name came from. But anyway, anatomy is structure, of course, and physiology is how things work, their function. We learn in biology anatomy from a couple of levels, although we've got far beyond this. We usually, in A&P classes, divided into what's called gross anatomy, which is working with a cadaver or visualizing things without any microscopic or other aid, and then histology. And both of them are very critical to understanding the system. And so we'll have histology labs where we'll look at all the structures under the microscope, and we'll also lots of figures in the lecture showing histological preparation. So definitely you can't learn how things work if you don't know how they're constructed. And finally, the classic description of physiology is chemical and physical processes necessary for life. But it's really an interesting, tremendously interesting subject. As a child, I used to take things apart constantly to find out how they work. And I think there's nothing more interesting than learn is how the body works. You can approach it from many, many different levels, from the molecular all the way through the gross anatomy. But it's the function of the system is really, really enjoyable, I think. So about the value of learning this material, I always start out with clinical practice first. It's impossible to understand pathology and practice therapeutics or even surgery if you don't know anatomy and physiology. It's the very first course you have in clinical programs, and you can't understand disruptions to normality if you don't even know what the normal is. So anyway, it's essential for clinical practice. And I think if a person has any interaction with others at all in the world, you're constantly discussing health, you're constantly, you have a sick relative or friend or family member, and you're going to the internet trying to find out what the illness is about and how the system works. There's very few subjects that are discussed less frequently, more frequently. So anyway, we'll discuss many different clinical problems as we go along. I had a rare SI at Boca. That's one of the few things I got out of some class. She said at the end of my class, I said, well, you've been a supplemental instructor in all kinds of A&P courses. How did mine compare? She said, I had no idea there was so much medicine involved in physiology. So I think because of my clinical experience, I'm constantly giving examples of drugs or phenomena that involve in any organ system. As I said, you can look at these anatomy and physiology subjects at many different levels. And these days in courses like 4023 or cellular and molecular biology course we teach, we talk about molecules a lot and how molecules work and interact. Definitely there's physiology of molecules. So a lot of what we'll talk about is things like transporters and receptors and so forth that are looking at our body on a molecular level. And then molecules work together as large macromolecules, as you know, and they form organelles that are part of cells that each have their own functions and different cell types, and make tissues, and tissue makes up organs and so forth. So anyway, you could look at this phenomena, anatomy and physiology, from many different levels, and we will. Most courses, as I already said in this subject, are divided into organ systems. We call it the organ system approach. And the book, the anatomy book, Martini, has a nice couple of figures on this that you might want to look at if you have the book. But they show each of these organ systems and their function, what their different functions, what they're trying to accomplish. And we'll do that as we begin each system. But it is kind of a nice introduction to what we're heading to. I just want to take the time. As I said already, we're going to start out with integument, which is, of course, the skin and its purpose, the skeletal system, muscular system, nervous system, and so forth. And then second semester looks like it's heavily weighted towards second semester, but we're going to do a lot of introductory material, a lot of anatomy and so forth first semester, and second semester will focus more on function of these critical organ systems. Before we talk much about anatomy, we have to have some ways of looking at the tissues and the organs from different standpoints. We call them planes. And so when we're looking at, for example, the heart, we look at it from this direction or that direction. These are ways to view these structures so we can talk about their function and their various parts and so forth. So a sagittal plane, as we show right here, divides the body vertically into sides. If you're nautical in nature, that would be the port and the starboard side, or right, left. So anyway, divides the body vertically from one side to another. And it could be mid-sagittal, which you would divide it equally, or there could be a sagittal plane in any particular position of the body. Coronal plane would divide another vertical plane, which divides the bow from the stern, or your ventral from your dorsal aspect. So that's pictured here in this plane. And then finally, a transverse plane shown here divides the water from the deck, or the bilge from the being on top of the deck, or superior from the inferior part of the body. So anyway, you should definitely know what these are, because we're going to all the way through the course say this is the sagittal plane to such and such, and you have to understand how you're looking at that particular structure. For example, this is a great example of the brain. If you see these figures and don't know what the plane is, it's really confusing. But if you know that this is a transverse plane, it really gives you a lot of information in coronal or sagittal. And so to understand what we're talking about, the first step is to know how you're looking, what aspect you're looking at that particular structure. Another useful set of terms in anatomy is, we call them positions, and it's how structures are oriented with respect to each other. I already used the term ventral and dorsal and so forth. So superior or cranial refers to, in humans, their head, and inferior or more used caudal refers to the feet, the lower aspect of the body. Anterior and ventral are both used interchangeably refer to the front of the body, and dorsal or posterior and proximal both used to refer to the back of the body. We use the term internal to refer to structures that are deep within the body, and superficial, those that are towards the surface. And when you're referring to a particular structure, or usually two structures in respect to each other, you can use terms like proximal, distal, and medial, lateral. So, for example, the shoulder is proximal to the thorax, and the fingers are distal. Medial is towards the center or deep part of the body, and lateral is towards the side. So anyway, we'll be using those terms while you're discussing the position of blood vessels or lymph nodes or whatever, so it's another cluster of terms that are very valuable to understand if you're trying to discuss the body. We also divide the body into regions for purposes of discussing different structures and their functions. And so cephalic refers to the head, and we use the term all the time. So I'm referring to structures or functions that are encompassed in the head. We talk about being cephalic. And that can be further divided into the cranial area, which is the area surrounded by the cranium itself of the skull, and facial, which is anterior to the structure of the cranium, and refers to the muscles and structures of sensory structures and so forth of the nerves, etc. So definitely those terms are divided up in most conversations. Cervical refers in body to the neck region, and the trunk is often subdivided into the thorax, the area above the diaphragm, and then the abdomen and pelvis, which are the chamber or compartment below the diaphragm. And there's no clear differentiation between the two. They're both really within the same compartment, but we definitely characterize what structures are in the abdomen and what structures are in the pelvis, and we'll do that as we move along. Upper appendages, of course, the arm, and the lower appendages, the leg. So those are just major body regions that we refer to constantly. We also will refer often to cavities within the body and also the membrane systems that are the boundaries of those compartments. And so in several different lectures, for example, even in histology, we're talking about the membranes and what they're composed of and where they're located and so forth. So the dorsal cavity is this area right here. It's also sometimes called posterior, but I think the predominant term used these days is dorsal cavity. And it consists of two sub-areas, if you want. They're not separate cavities because they're interconnected. The cranial portion and the vertebral portion. So the cranium, of course, contains the brain, and the vertebral cavity portion contains the spinal cord. All of those together are called the dorsal cavity. The ventral cavity is, of course, in front of the dorsal, or more anterior to the dorsal cavity. And then it is further subdivided, as I already said, to the portion above the diaphragm, which we call the thorax. And you can further subdivide the thorax into the areas surrounded by the pleura membrane and visceral or parietal pleura. And those are where the lungs are located, so those are pleura cavities. And the central pericardial cavity is surrounded by its membrane, we'll talk about in a second. And then the lower or more inferior cavity within the ventral cavity area is referred to as the abdominopelvic altogether, but you could subdivide it into the abdomen and the pelvic. Again, there's not clear delineation between the two. It's mainly based on the structures within. The membrane systems that we're going to refer to that divide these cavities are complex structures made up of an epithelium, usually a single layer, called simple epithelium, and connective tissue, consisting of basal membrane and often other components. So it's a combination of epithelium and connective tissue, and we're going to define those very strictly in a bunch of these very soon. And they cover tissues within these compartments. They separate tissue from one another, and also they support the viscera in many cases in the positions that they're in. Otherwise, we couldn't have the function which we do. I don't know how we ended up with B and C up there and then A down there. We still have my outlines split up. Membranes can be classified as whether they're serous or mucus, and the main difference is the constituent within a mucus solution, which is a polymucosaccharide, which gives it a viscous or lubricative quality. So a serous secretion, and we'll talk about the glands that produce these later on, is mostly an aqueous solution. It usually has salt, and these membranes that line body cavities produce this type of fluid, and so they're called serous membranes. And these are subclassified into two groups. A pleura membrane is one which is in the thorax and has to do with pleura. Pleurisy, names or words that have that word in them refer to the lungs and respiration. So anyway, pleura are the membranes that line the thorax, and you'll hear these terms over and over again. So a visceral pleura is a membrane that is against the lung or adheres to the lung itself, where the parietal pleura is against the chest wall. So in the thorax, we have a thin membrane that lines or covers the interior surface of the thorax. We call that a parietal pleura. And then we have one that's against the wall of the lung. We call it visceral pleura. Well, if there's two membranes, there has to be a space in between them. And that's called, as it says there, pleural cavity. And if you, for example, have fluid in your, gets into your pleural cavity or an infection, can have serious consequences. Usually the cavity only has a few milliliters of fluid, and it's for lubrication between the lungs opening and closing and the chest wall. But if you have a buildup of fluid or even air in that cavity, you can have very serious complications. Talk about that later. Kind of poor representation of pleural cavities. The area in between the two pleural cavities is called the mediastinum, and it houses the esophagus. It just goes through the area of the heart, major vessels, and spine. So if you hear that term mediastinum, it really refers to the area between the two pleural cavities. The heart itself is also surrounded by two membranes, and again, you'll notice the word visceral and parietal. So the membranes surrounding the heart are colloquially called pericardium, which just means around the heart. So the membrane against the heart itself is called visceral pericardium, and the ones outside of the heart, just barely, so it's in the mediastinum, is called the parietal pericardium. And in between the two, again, there's a cavity called pericardial cavity. So they're trying to show where that is. It's, as this very simple-minded illustration, it's like pushing in balloons, so you have a little compartment in between. And the same value exists with the pericardial cavity. It's again, so the heart, if you can see it beating in your chest, is a vigorous structure. But anyway, when it beats and undergoes systole and diastole, et cetera, this prevents it rubbing against the lungs and so forth, and reduces the friction in tissue surrounding. Again, the same problem exists if this pericardial cavity is invaded. Tamponade is an extremely serious problem. T-A-M-P-O-N-A-D-E. Tamponade is when you end up with, it could be an infection, but usually what happens is a vessel breaks, but all kinds of things. When fluid builds up within this cavity, it creates pressure within the cavity that prevents the atrial from filling, and it leads to a very insidious, very quick death, unfortunately. Usually it's not realized until a patient's already dead, cardiac tamponade. But anyway, so it's very critical to maintain this diffuse volume, the 2 mils of volume in that compartment. Peritoneum is the names which we use for these membranes in the abdomen, just like in the thorax. There's a visceral peritoneum and a parietal peritoneum. So the same thing, the visceral is against each of the organs, small intestine, large intestine, liver, spleen, etc., within the abdomen, and the parietal lines the outside of the abdomen, or abdominal pelvic area. There are some folds of the peritoneum that are double, so they come in and come back out. Here's a nice picture of one. And these are called mesenteries, and they kind of hold up it's like some rope we use to hook the intestines and so forth to the walls of the abdomen, so that, you know, your stomach and your intestines aren't just flapping around in there. They're actually hooked up to the walls of the container. So anyway, those are called mesenteries. And if you have lab, we can dissect the cat and see mesenteries and so forth in the abdomen. So all of that was all referring to serous membranes. There are also mucous membranes in our body. And again, as we said before, they have a lubricating type of material because of those glands that produce them. And they're in cavities that are open to the exterior, like oral and nasal cavities, respiratory tract, reproductive tract, and so forth. And that's it. So anyway, we'll start here when I see you on Thursday. Have a good break, and